Hey kiddos, welcome back. Today we're going to be talking about 1.3c, or day 3, okay? Today we are going to be talking about something called the distance formula. And the distance formula is to find the distance between 2 points on a graph. The distance formula is d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. I'm going to leave our distance formula right up top so we can always reference it. Let's jump right into the first example. So for number 1, we have a point R, which is at 1, 3, and a point S that is at 4, 2. So just like with our midpoint, we have our x-axis and our y-axis and our x then y points, which means first we're going to move horizontally on the x-axis and then vertically on the y-axis, okay? So I already graphed these points for us. I'll just go over how I got to R. So from the origin, where we always want to start, I went right 1 because we have a positive 1, and down 3 because we have a negative 3. Okay, I graphed S the same way. So now let's go ahead and set up our formula. So I'm just going to draw our D is equal to our giant square root. I'm going to make R our 0.1 and S our 0.2. It does not matter. You can switch them up if you want to. So our 0.2 holds our x2. So I'm going to use 4 minus our x1, which is 1 squared, plus our y2, which is 2, minus our y1, which is 3, which is negative 3. Minus our y1, which is negative 3 squared. So first thing we have to do is we have to simplify. Okay, I'm going to keep our d is equal to our giant square root. 4 minus 1 is 3, and I'm going to keep that in parentheses because it's still squared. Plus 2 minus a negative 3. When we minus a negative, we're really adding a positive. So 2 plus 3 is 5. And again, I'm going to keep this in the parentheses because we're squaring it. Okay? So next line, d is equal to our giant square root. 3 squared, or 3 times 3, is 9, plus our 5 squared, or 5 times 5, is 25. Okay, next line, d is equal to 9 plus 25 is 34. And once we plug that into the calculator, we have d is approximately, that's what those little squiggly lines means. It means it's around 5.83. So the distance between R and S is 5.83. All right, so for our second example, we have our point A at positive 1, positive 4, and our point B at positive 3, negative 2. Okay, so I'll switch this up from last time. I will make our A our 0.2 and our B our 0.1. I already went ahead and graphed these, so I'll show you how I got A. Starting at the origin, I went right 1 because it's positive, and then up 4 because 4 is positive. So let's set up our equation. We keep our D is equal to our big square root. Parentheses, our x2 is a 1 minus our x1, which is a 3 squared, plus our y2, which is 4, minus our y1, which is a negative 2 squared. Okay, next we got to simplify. So d is equal to our giant square root. 1 minus 3 is a negative 2 squared. I'm going to keep that in the parentheses because we're squaring it. Plus 4 minus a negative 2. When you minus a negative, you're really adding a positive. So plus 6 squared. D is equal to our giant square root. -2 times -2 gives you a positive 4. Plus 6 squared, or 6 times 6, gives you a positive 36. D is equal to our big old square root. 4 plus 36 is 40. And when we plug the square root of 40 into our calculator, we get D is approximately 6.32. So the distance between A and B is 6.32. All right, so for number 3, I already graphed it for you. We have point C at +1, +2, and point D at +7, +8. Okay, I already graphed this, so I'll show you how I got C. We start at the origin. I went right 1 because we have a +1 and up 2 because we have a +2. So, set up our equation. We have D is equal to our big old square root. I'm gonna make C our point 1 and D our point 2. You can switch these around, it doesn't matter. So we have our x2, which is 7, minus our x1, which is 1 squared, plus we have our y2, which is 8, minus our y1, which is 2 squared. We have to simplify, so we keep our D equals our giant square root. 7 minus 1 is 6 squared, plus 8 minus 2 is also 6 squared. So D is equal to our big old square root. 6 times 6 is 36. 6 squared, or 6 times 6, is 36. D is equal to our big old square root. 36 plus 36 gives you a 72. And that means D is approximately 8.48 when we plug it into the calculator. So the distance between C and D is 8.48. All right, so for number 4, we have point E at -4, +3, and we have point F at -6, +5. So I'll just show you how I got to point E because I already graphed it for you. Starting at the origin, I moved left 4 units because we have a -4, and up 3 units because we have a +3. So let's plug it into our formula. We have D is equal to our big old square root. I will make E a 0.2 and our F our 0.1. You can switch these around. It does not matter. So our x2 is our -4 minus our x1, which is a -6 squared, plus our y2 is a 3 minus our y1 is a 5 squared. Next we have to simplify, so we keep our D is equal to our big old square root. -4 minus a -6. When we minus a negative, we're really adding a positive. So -4 plus 6 gives us a +2, plus 3 take away 5 will give you a -2. Okay, we keep our D is equal to our big old square root. 2 squared, or 2 times 2 gives you a 4. -2 squared, or -2 times -2, also gives you a +4. So we keep our D is equal to our big old square root. 4 plus 4 is 8. And when we plug that into the calculator, we get D is approximately 2.83. So the distance between F and E is 2.83. We have a point G at -8, -6, and a point H at -4, +10. Okay, so I'll show you how I got to G. From our origin, I counted left 8 because we have a -8. And from there, I counted down 6 because it's a -6. All right, let's set up our formula. We have D is equal to our big old square root. I'm gonna make G a 0.1 and H a 0.2. So our x2 is equal to -4 minus our x1 is a -8 squared plus our y2 is +10 minus our y1, which is a -6 squared. First things first, we gotta simplify, so let's keep our D is equal to our big old square root. -4 minus a -8. When you minus a negative, you're really adding a positive, so -4 plus a +8 gives us a +4 squared, plus 10 minus a -6. When we minus a negative, we're really adding a positive. So 10 plus 6 gives us a +16 squared. Keep our B is equal to our big old square root. 4 squared, or 4 times 4, gives us a +16, plus 16 squared, or 16 times 16, gives us a 256. We keep our D is equal to the square root of 272. When we plug this into the calculator, we get D is about 16.49. So the distance between G and H is 16.49. All right, kiddos, just to show you how to use your phone's calculator to find the square root and use squares, I'm going to go ahead and show you how to do it here. So our last example, we had to do the square root of 272. So first thing you're going to do is you're going to turn your phone sideways, and it's going to open up all of these extra buttons. Okay, I'm going to type in 272 and then hit the button that looks like this. And that will give you your 16.492 that I showed in the example. Another way to find the square root is by Googling just calculator. Okay, Google has a calculator here that if you hit this mode, you are able to see other things. You want to hit this button, which will give you the square root. Go back to numbers, 272. And that will again give you your 16.492 to give you the same answer.